Hello, this is Dr. Mode, and in this video we are going to be working out the 5 problems on the Solution Review Problems worksheet. Question number 1 says, what is the molality of a solution that contains 90 grams of copper 2 sulfide dissolved in 700 milliliters of water? So the first thing that we need to do is we need to find the molar mass of copper 2 sulfide. And here it is. It's 95.612 grams per mole, and that's just one copper atom and one sulfur atom added together. The next thing is we need to take the 90 grams and convert that to moles using this molar mass. And here it is. We get 0.9413 moles. Now what we have to do is calculate the molality. And remember, molality is moles of solute over kilograms of solvent. So here it is right here. You'll notice that on the bottom of the fraction, the 700 milliliters of water corresponds to 0.7 kilograms. And our answer is 1.34 molal. Here's question number 2. It says, what is the molarity of a solution that contains 230 grams of sodium nitrate dissolved in 489 milliliters of water? So again, the first thing that we need is the molar mass of sodium nitrate. So here it is. It's 85 grams per mole. We're going to have to take the 230 grams of sodium nitrate and convert that to moles using this. So again, we'll divide by the 85 to find 2.706 moles of sodium nitrate. Molarity is moles of solute divided by liters of solution. So here we take the 2.07, the 2.706 divided by 0.489 liters, and we find the answer is 5.53 molar. Question number 3 says, if you had a 3.4 molar solution that was made by adding 45 grams of H2S to water, how much water did you use? So again, the H2S has a molar mass of 34 grams per mole. We're going to use the fact that molarity equals moles over liters, but we need to find out how much water did we use. So we actually have to rearrange this and solve for liters. So liters is going to be moles divided by molarity. So in the problem, we've been given a molarity, but we still need the number of moles. So we're going to use that molar mass of 34 grams per mole to convert that 45 grams into 1.3235 moles of H2S. Now we can plug it into the formula. We've got the moles on top divided by the molarity on the bottom, and we find the answer 0.389 liters. Question number 4 says, what is the freezing point depression of a solution that contains 8 grams of sodium chloride dissolved in 90 grams of water? So we need the molar mass of sodium chloride. It's 58.44 grams per mole. The formula for freezing point depression is delta T equals negative 1.86 times the molarity times I, which is the number of ions. So for sodium chloride, because it's an ionic compound and it dissolves into 2 separate ions, one sodium and one chloride, the I is going to be 2. So that just leaves calculating the molality, the little m. So we'll use the molar mass of sodium chloride to convert the 8 grams into 0.137 moles. And now we can plug that into the equation. The bottom of the molality fraction is in kilograms, so we have to move the decimal place over 3 times to find that 90 grams of water is 0.090 kilograms. And when we plug all this in, we find the new freezing point of the 8 grams of sodium chloride and 90 grams of water is negative 5.66 degrees Celsius. Question number 5 says, what is the freezing point depression of a solution that contains 8 grams of MgCl2 dissolved in 90 grams of water? So, the difference between this problem and the last one is that we've only switched the sodium chloride to magnesium chloride. So, two things have changed. One, the molar mass is now higher, and two, instead of there being 2 ions, we now have 3. You've got 1 magnesium and 2 chlorides. So the molar mass of MgCl2 is 95.21. Again, we're going to use the same formula for freezing point depression. The 8 grams needs to be converted into moles, and here's the answer for that. And now we plug those things into the formula. Again, I is now 3 in this formula because there are 3 ions, and we find the answer is -5.2 degrees Celsius.